Hi, and welcome back to my channel, The Opinionated Science Educator. When I was teaching, I was appointed by the Department of Education on an ad hoc basis to mark the physical science papers. So marking the papers gives you a good indication of the types of errors that students often make. Students forget to put units or they put the incorrect units. So today's support lesson is looking at the importance of knowing what the different units are and when doing calculations to include units. In part 1, you saw why it was important to know units. It caused Joey a big problem. If you can remember, Joey received a call to go pick up 1 gold, so he rushed off thinking it was an easy job, only to discover it was 1 ton of gold, and 1 ton of gold is 1,000 gold bars. As Joey walked home, he thought, I really thought it was 1 gold bar. 1 bar is 1 kilogram, but 1 ton is 1,000 gold bars. I would have made a plan. As you watch this video, I hope you can see that not including units or working with incorrect units can be a costly exercise. Let me tell you about NASA's biggest mistake. It involved an orbital being sent to Mars to do some environmental measurements there. So NASA, and this was a headline, when NASA lost a spacecraft due to a metric math mistake. In September of 1999, after almost 10 months of travel to Mars, the Mars Climate Orbiter burned and broke into pieces. On a day when NASA engineers were expecting to celebrate, the ground reality was completely different. All because someone failed to use the right units, in other words, the metric system. So let me tell you about the 2 protagonists in this story, NASA's Jet Propulsion Laboratory and Lockheed Martin astronauts. So the navigation team at the Jet Propulsion Laboratory used the metric system of millimeters and meters in its calculations to get the orbiter safely on the surface. But Lockheed Martin Astronautics in Denver, Colorado, who designed and built the spacecraft, provided the crucial acceleration data in the English system of inches, feet, and pounds, which America still uses today. The result, the orbiter crashed into the surface of Mars. The metric, English, whatever. But this was a huge mistake. It cost a lot of money that was chucked out of the window, or should I say crashed into the surface of Mars. The Mars Climate Orbiter cost $125 million to build. Now, if you forget units, it won't cost you millions of dollars, but it will cost you a distinction. There goes the curtain down on your dreams. So, this is from the metric marking guidelines. You will only be penalized once for the repeated use of an incorrect unit within a question. So at least you only throw 1 mark away. You also only need to put the unit for your final answer. But marks will only be awarded. So you're not going to get a mark if you get the correct unit but the correct answer. So to get the final mark, you must have you will lose a mark if you have the correct answer and the wrong unit. No mark. Wrong answer and correct unit, no mark. Correct answer and no unit, no mark. That is throwing marks away. As much as 10% of the paper consists of answers with units. And 10% is the difference between 79, or should I say 70 and 80, or 30 and 40. Don't throw marks away. At the beginning of the first video, I said we'd also look at scalar and vector quantities and what the difference between them is. So scalar quantities are physical quantities that have magnitude but no direction. And mathematically, they're described by a number and a suitable unit. And these quantities can be added and subtracted together by simple arithmetic rules. There are some examples such as distance, speed, mass, energy, density, power, length, area, volume, time, temperature, and work. Now, vector quantities are physical quantities that have magnitude and a direction. And these quantities are completely described by a number a suitable unit, and a certain direction. And we cannot add these simply using arithmetic rules. That is why there's a whole section on vectors in both the grade 10 and the grade 11 curriculum. Examples: displacement, velocity, weight, acceleration, force, impulse, pressure, and so on. So to end this video, I'm going to look at the international system of units that the people at Lockheed and NASA messed up with. These are called the SI units, and there are 7 base units because there are 7 base quantities. In other words, these 7 quantities are not dependent on each other. And this is used by the majority of scientists in the world and in countries in the world. So the first is length. The symbol is can be length, height, or radius. Time is a small t, temperature, capital T, mass, a small m. Electric current is the symbol I. Amount of substance is n, and luminous intensity is there used with the I. Now the units for length are meters. For time, seconds. For temperature, Kelvin. Mass, the SI unit is the kilogram. For current, it is the ampere. For amount of substance, it is the mole. And for luminous intensity, it is candela. So those are the 7 SI base units. All our other units are derived from those 7 units. And they are defined in terms of those quantities by mathematical equations. Remember, I said think about units like algebraic expressions. So let's look at just some derived quantities. Area is a length times a length, symbol capital A. Its SI unit, meters times meters, would be meters squared. Volume is a length times a height. Its unit is cubic meters. Meters times meters times meters gives meters cubed. Speed or velocity, well, actually velocity is a length divided by time, and the unit is meters per second, or m/s, or m to s to the minus 1. Acceleration is velocity over time, and that's meters per second squared. And the unit is m times s to the squared. Density, which we looked at in video 1, is mass divided by volume, so it's kilograms per cubic meter. Magnetic field strength is the current divided by length unit, so its unit is the ampere per meter, and concentration is amount of substance divided by the volume, so it's mole per cubic meter. So those are some of the derived units, and they are mathematically expressed. Here are a whole lot more. I'm not going to go through these in the same detail, but things like frequency, force, pressure, energy, power, electric charge, and so on. Now, these units are all derived from the SI units. And what we do is to honor certain scientists, these units are given a special name. The derived units are often named after the scientists who did the most work in the field. So Newton for force and Tesla for magnetic field flux. Thanks for joining me for this video. I hope that you found it useful and the previous one. So until next time, goodbye, and thanks for joining the Opinionated Science Educator.